Okay, I wanted to look at a couple ideas that appear on this AP Classroom review that seem to need a little bit of work. And the first one is the limit definition of a derivative, which came up on a couple problems. I specifically saw it on problem number 30 and 33. I feel like I saw it one more place, but now I'm not finding it. So regardless, those two problems, let's talk about that limit definition of a derivative. As a reminder, the limit definition of a derivative says the limit as h approaches 0 of the algebra 1 slope. So as h gets closer to 0. So if we take a function evaluated at x plus h and then subtract f of x. So this is our change in our y. And what we're trying to do is make that change go to 0 so that that change in y is as close to 0 as possible. Thus the limit as h approaches 0 over, normally it would be x plus h minus x, the definition of a slope. We can simplify that. So the limit definition of a derivative that we have been accustomed to is the limit as h approaches 0 of f of x plus h minus f of x over h. Now, when we get this problem, or when we've had this problem in the past, let's say, for example, I ask you, using the limit definition of a derivative, to find the derivative of x squared. We know what this is. We know we could do this very easily, but let's look at the limit definition of a derivative. This is telling me I'm going to take my function and evaluate it at x plus h, and then subtract the function over h. Now, if I were to take the limit right now, I would get the indeterminate form. I'd have 0 over 0. And so what we've done in the past is we then rewrite this by expanding that binomial. So x squared plus 2xh plus h squared minus x squared over h, and do some simplifying. I'm just going to come down here. So the limit as h approaches 0, let's combine like terms. We get a 2xh plus h squared. I'm going to go ahead and pull out an h. So we get h times 2x plus h over h. The h's cancel out. And we end up with the limit as h approaches 0 of 2x plus h, which just gives us 2x. We knew that. We could have used the power rule so much quicker and gotten that derivative. Okay, so why do I show you that? Because before, if I then would have asked you to evaluate this derivative, the derivative of x squared, say, evaluated when x is 3, what we would do is we would go through and take the definition of the derivative using the limit, and then we would evaluate this when x equals 3. So we would get 2x evaluated at x equals 3, which we know to be 6. Great. Okay, why do we say that? Because this problem could have been asked a little bit differently on the AP exam. This problem could have said something like the limit as h approaches 0 of, and we could have written this problem like this, 3 plus h squared minus 3 squared over h. Okay, so this problem is not actually asking me to take this limit. That's not what it wants. What it wants me to do is to use the idea of the limit definition of a derivative and understand that what is happening here is I'm asked to take the derivative of some function squared, so like 3 squared, but I'm asked to take that derivative evaluated at 3. So you should be able to look at this problem, and what this problem is actually telling you to do is take the derivative with respect to x of x squared when x is 3. Okay, let's look at an example. Let's go to example on that AP Classroom first semester review. Let's look at problem number 33. Let's see if I can scroll this. Scroll this. Oh, fabulous. Scroll this all up. Okay, if we look at problem number 33, 33 says the limit as h approaches 0 of e to the negative 1 minus h minus e to the negative 1 over h. Okay, so if we notice that this should fit the pattern of the limit definition of a derivative, which is x plus h minus f of x over h, then what this problem is actually asking me is to find the derivative with respect to x of e to the negative x evaluated when x equals 1. Let me explain why. Okay, if what we're working with is this e to the negative x, and I use the limit definition of a derivative, which says limit as h approaches 0 of f of x plus h minus f of x over h. F of x plus h would be e raised to the negative x plus h minus, e to the negative x over h. Simplifying that numerator, the numerator, we'd get e to the negative x minus h. And you could see then that this fits that pattern that we have right up here. That's why it's negative x. Well, e is a nice easy derivative, and the derivative of e to the negative x using the chain rule is negative e to the negative x, and I'm evaluating it at x equals 1. So I get negative e raised to the negative 1, which gives me negative 1 over e. Don't remember what answer choice that was. Let's see, B looks like. And so that's problem number 33. Okay, let's extend that idea. Let's extend that idea a little bit and look at a different limit definition of a derivative. The limit as x approaches some number a of f of x minus f of a over x minus a. This too is a limit definition of a derivative. Usually this limit definition of a derivative is at a specific point. That specific point is a, so we're trying to find that limit. So you had a question on AP Classroom Review, I think it was number 30, that says the limit as x approaches 2 of the natural log of x plus 3 minus the natural log of 5 over x minus 2. Okay, so let's talk about what this looks like. In this form, this piece of information right here is my function. What I'm hoping to take the derivative of that function is at this number a here. Okay, so we have that 2. So really what this problem is asking me to do, using the idea of a limit definition of a derivative, is to find the derivative with respect to x of the function, the natural log of x plus 3, and I'm going to evaluate it when x equals 2. And so we know then that the derivative of natural log is 1 over that function. It would have a chain, but the chain is just multiplying by 1. I'm going to evaluate it when x equals 2, so we get 1/5. And that's how the limit definition of a derivative works. And I can almost guarantee that one of these questions will be on the multiple choice part of your AP exam. They are very fond of understanding what the limit definition of a derivative is. Hopefully that helps.